does come over to the Indiana Musical. That is always the last Saturday in February. They do close it out at 900 people because that's all the lunches they can make at Decatur High School in that amount of time. And it does get cut off. So Matt's saying it is open to register. Get your registration in. It's a win-win. And we all like to go as a club. I have shirts and hats. Everyone needs to have their shirt and hat. But please plan to go to that. Very, very worthwhile. The last Saturday in February. Anything else? Okay, so Isaac, you said you were going to go first? Because you're going to, I thought Isaac could. Okay. All right, so Paul's going to run your PowerPoint for you. Thanks for, before we start, the top bar is here. After 3 months in Karen's truck, it's here. It's in great shape, and it's going home tonight. If you have a blue ticket from this raffle, which you're supposed to have with you, raise your hand. Who has a blue ticket and is here?
I know my number is at home.
Well, okay. This is what I was told. Whoever was here tonight with their ticket was to write their name on the back of their ticket, and we're drawing from the tickets that are here tonight. It's going home to somebody.
Okay. If you wrote her name on the ticket, and we don't have
Okay. Well, if you want to do that, then I'll have to wait because all the tickets are in Jim's car at the airport.
Oh.
But we did announce on
No, the tickets that we kept of your halves are in his car at the airport. So that's why we were going to send it home tonight with whoever was here with their ticket. We were going to have to write name. So, okay, well, we'll commiserate in the back and decide what we want to do, but it is here. And I also have new items to raffle for tonight. Ron generously donated a bromomite testing kit from the University of Michigan State and University of Maryland. So we have this to raffle off. And he also has that awesome beehive wrap that he brought last month and endorsed so heartily. I have that. So, and then I have a brand new smoker, and it's a beauty. So we will sell dollar tickets. Do I have tickets? Wait, we don't even have any tickets.
They're in Jim's car at the airport.
They're in Jim's car. No, they're in Jim's car at the airport. How will I raffle without tickets?
You've got pieces of paper to the slips.
Yeah, everybody wrote their
And
name
you
on the
guys
ticket.
will be in charge of cutting pieces of paper with slips. Okay, all right, so we'll raffle those off at our mid-break. All right, Lucas, I'm ready.
Boy, this is my first time doing a presentation, so
That's totally fine.
and but here we go. So hello, my name is Lucas George. I am the one of the two of the beekeepers that young beekeepers that are here. So and I was asked, can I want to do a presentation on bees? And so I was trying to look for something that all beekeepers want to know more about. And as a young beekeeper, as I started out this year, diseases and ways to prevent them. So there are a lot of killers of honeybees, mites, and parasites. In this presentation, I'm going to exploit these and tell the best ways to get rid of them and defeat them. Burrow mites. I'm sure all you guys have heard of them. Burrow mites are a main killer of honeybees. The reason why is burrow mites by themselves are not the ones killing them, and that's kind of confusing. But burrow mites, what they do is they weaken the hive. Once they weaken the hive, other bees come in and finish them, or wait for them, and burrow mites get the credit. That's why they're one of the main killers of honeybees. So as you can see, as I just explained, diseases and mites do not kill by themselves. They need help most of the time. So what they'll do is they'll weaken the hive to a state that it cannot survive, and then wax moth or small hive bee will try to explain, or winter will come in and kill them all. The ways to prevent burrow are regular checking for burrow. Now, you've heard of the sugar shake that you would put the bees in, heat them up, burrow mites fall off, you can count them. And then there's a new one back there that you put rubbing alcohol in, I think, and it kills the bees, but the burrow mites fall off. So you're killing 300 bees to prevent your whole hive from basically dying. And also to make sure your colony has plenty of food if there are signs, and period. also an oxalic vaporizer. I'm sure you guys have all heard of that, because I think someone did a discussion on that a couple weeks ago, or months ago. So that's also very effective. Chalk room. How many of you guys have heard of chalk room? Chalk room is a spore-forming fungus that infects the gut of the bee larva that is consumed through larval foods, which then infects the gut. So chalk room is a fungus that forms. The ways to help prevent or reduce the fungus is increase ventilation in the hive. So increasing the ventilation in your hive is going to be different on multiple different steps. And also the colony lacks food stores and feed. The colony will most of the time, what they'll do is they'll take the brood that is infected and bring it outside of the hive and throw it out. Most of the time, but you can help them do that before it spreads. Tracheomites. Tracheomites are microscopic that feed and breed in the trachea of bees, eventually suffocating them. There are a few treatments to tracheomites. They're very hard to get rid of. The main treatment is menthol in a gas form, also a vaporizer for veromites. It basically goes into a gas, goes to the hive, and hopefully kills some of the tracheomites. Also, you get a queen that's mite resistant. That means the mite breeds slower in the trachea of bees, so you have more time to react. Small hive beetle, or SHB. This beetle preys on weak hives, but when it gets too weak, it goes to find another hive. So what they'll do is they won't prey on giant hives because they can't really get a foothold. But when they're getting hives that are just coming out of winter and aren't at their strongest point yet, they'll come in and they will go in and they will run through the honey. They will lay their eggs, they'll breed, and eventually the bees will. They go and when they defecate, the honey crystallizes. So that's not very good. There's one attribute about the small hive beetle that was worth mentioning. They can pick up the same antenna movements and clicks as drone. So what they do is they trick the bees into feeding them, which they stay alive and have other people feed them. Who doesn't like that? Most of honeybees, what they do is they'll chase the mites around in cracks and crevices. Then what they do is they'll seal it up with wax or compost to keep them in there. Although there are some bees that do that better than others. There are multiple ways to combat them. One is you can get queens that are more effective at killing them, or you can get traps. Or you can get a screen fireboard and put a sticky board in to trap them. Those are all effective ways of getting rid of SHB, but the sticky board's not the most effective. Because normally the bees won't throw them off, but sometimes they do. Wax moths. They're not a very big threat to beehives with lots of bees in them. They normally affect supers that are not harvested or extra hive bodies and frames. They just basically go in and destroy it all. After the first freeze, though, you do not need to worry about them because they go into sort of hibernation, so they're not active until next spring. These are just a few of the funguses and mites that threaten your hive. Now you shouldn't fret that your hive is going to die because there are so many. That's not true, though you still need to be proactive about it. If you're not, then they will get to your hive. They will get to your hive and possibly kill it. So you're not supposed to freak out stage. Oh no, what do I do? But you're still supposed to be active in checking it for diseases. Questions? I feel like I went through that really fast.
I have a question. How many of those things have you observed in your hive this year?
Small hive beetle and varroa. Those are the really only ones I've experienced.
And what method do you use on your burrow?
Varroa, we use Mystrix. And small hive beetle, I've not done anything really. So.
Is that hive with your hive beetle in the shade?
Yeah,
I hear they like shade more.
Yeah. Thank you. That's all I have.
Great.
Can I
beekeepers will do at the fall meeting?
Well, I'm not exactly sure, but, they both, you present a whole presentation and you write out several paragraphs, I guess, and you present it in document. Mr. Tony Dan this year was in charge of going through all this, and he had more than they've had in several years, so.
Oh, good.
And there are 2 age groups, and, is it up to 15 years old?
12 to 16, then 17 to 22.
And so they select 3 finalists from each age group, so there will be 6 presenters, 3 from each age group, and there will be a kind of like a panel of judges, I guess they would you'd say. And so they're gonna ask each of them questions and go over their report. And I don't think Mr. Tony Van does that, he was just selecting 3 of each.
Right.
So there'll be other people that do that, and so,
Individually, not as a group, right?
I'm not in a part of it
Okay.
anymore, so I don't know that. And so I think if you're a finalist, you're guaranteed a prize, is that correct? And the top prize is?
$250 just plain cash, $300 beekeeping supplies, which has not been specified. The second prize is $100 beekeeping supplies, and the same $300, sorry, $100 cash, $300 beekeeping supplies, same. Then the last one has the beekeeping supplies money and $50 cash.
So you're
The
guaranteed a
group
prize.
prizes in the older group, the winner was $1,000
$1,000.
cash, a full hive.
Kind of like a scholarship.
Yeah, it
for
was a
the-
wonderful prize.
For the older group, so, and then, and like I said, they both were very deserving, but they had they had more entries than their workplaces, so, and you can see, Lucas was obviously very deserving from that presentation. Isaac got chosen as a final, so Isaac and his parents they put him in a hotel room, so they have to get themselves there, but they get a hotel room, and he's done great for.
Absolutely. All right, I think we're ready for you. That would be great. Thank you.
Same thing, hands in, we vote.
So as you can tell, this is my presentation about one of the many mites that Luke mentioned, the varroa destructor. As you can tell by that really zoomed in ugly bug right there. That hangs on the back of a bee, normally. Now, the main problem with the varroa destructor is the fact that the mite will go onto the back of a bee. And size comparison is, imagine a bug that sucks your blood the size of your fist on your back, but you can't get it. That's how a varroa destructor is to a bee. And it sucks the hemoglobin of the bee, which is like our blood from a honeybee. And through it's kind of like a mosquito, how when they bite you, they can pass on diseases, as we all know from the Zika virus, which is spreading down in Florida. But they can pass on diseases such as deformed wing virus, parasitic mite syndrome, and acute bee paralysis virus. This is a picture of the deformed wing virus. As you can see, their wings are shriveled and useless, and they cannot fly at all. Next, this is like the CC colony collapse disorder, is what some of this is about. The colonies are collapsed somewhat because of the varroa mite, which can transfer diseases and also weaken the bee's immune system. And the mite attacks normally the stronger hives, and then whenever a hive starts to weaken and it's like gonna die, the mite will just grab, and you know when bees rob other weak hives? Well, the mite will just jump off the weak bee and jump onto a strong bee and go straight to that strong hive. So they have a really effective way of going into hives and killing them. But don't worry too much because there's plenty of ways to combat them, such as further on nutrition. And if the varroa mites do not kill, then the diseases will, such as all the other stuff. Because when the bees weaken, all their cleaning, their hygiene of the cells, and opening up the brood stuff, that all weakens too. So you can American chalk brood and also American foul brood, European foul brood, which is a weaker to it. And the disease, American foul brood, also compromises everything. You have to burn it practically to just prevent the spread because of how effective it is. European foul brood, you can actually, the bees can come back from, but American foul brood, it's kind of just done. This is what normally someone's colony collapse would look like. Tons of dead bees, just solutions. Mites can be directly treated, unlike what it says on there, but eventually the mites can develop a resistance to certain treatments, and it can become less effective. A lot of just hobbyist beekeepers, like I am right now, do not treat just because it's a hassle. It can cost a lot of money, but commercial beekeepers will definitely treat because that's how they depend on it. Things that the hive that I have, also that Lucas does and Mr. Evans does, is Purdue bees, which are called ankle biters, which are they're bees that have been the queens have been machinely inseminated with certain traits, and they're called ankle biters because they will actually gnaw the legs off the varroa, and they will either bleed to death or they'll just fall off. So they can be really effective in going against the varroa mite. This is the varroa with the chewed off legs, or the ankle biters. And the next, what I gathered from the outline of what they were planning to do when they asked for the money to do this project, is they had identified all like the genes that cause the good hygiene and just all the cleanliness of the hive and getting the varroa off. Because I said before, the varroa are really effective because I've also heard that they can make a pheromone, which is it smells exactly like a bee to a bee, so they can just blend right in, kind of like active camouflage to the bees. But they depend on pheromones for the sting. That's how they know that, oh yeah, sting this, because there's the attack pheromone and the queen pheromone, which lets them stay in the hive. Then there's the grooming gene and genes that occur in aggressive behavior. Now this is dead honeybees that have been cleared out by other bees, and that's part of hive cleanliness. They're clean out the dead bees to keep from just infection and stuff. And the queen testing, which is what Mr. Evans is actually part of. Is that Purdue will give machine inseminated queens to Mr. Evans and a few other people, I think. And beekeepers will return samples of honeybees and mites so they can figure out, are they biting the legs off? Do we need to fix this? Is it not working? And then Purdue will measure how many mites have legs bitten off, and normally about 40% is a really good percentage for how many mites. Those are my sources. And also, if you want to look around back, after this is done, around back, there's 3 sticky boards, which are hives that are put in the hives in 24 hours with a mite strip, and they take them out, and one of those is a Purdue one, and 2 of
we're gonna go through this month. He had some leftover points that I'm just gonna read through with you. And then I also have a printout. Randy Oliver recommends this circular from the USDA from 1940, and I went through it today, and it has some really great insight that is very applicable to us today. So nothing that goes on in this talk is original. It all came out of this article through Jim to me. But I think the honeybee is such an amazing thing. There's always something more for us to learn, and there's always something that we can glean from that. How many people get the ABJ? How many of you get the American Beekeeping Journal? American Bee Journal. How many people read the ABJ? Well, good. I'm so glad. How many people get bee culture? I get bee culture. Okay, but it's good to see it. Unless I can't hear it, it's tablet. Recapping last month about the winter cluster, two separate phenomena take place in the winter cluster. One is the cessation, the ending of brood rearing, in response to a lack of incoming pollen, not to the length of the day, not to the cold temperature, but to the lack of the incoming pollen, which I found really interesting. And the second thing that is happening at that same time is the need for the colony to conserve energy during cold weather. Both of these occur concurrently in cold weather climates like ours, but they are not linked to the time of the season, the amount of daylight, or the temperature. These responses overlap, but are independent of one another. He goes on to talk about in arid or subtropical areas, the colony will shift to survivor mode during late summer due to lack of pollen or nectar. That may include absconding or migrating to a new location. These were other species of bees, not the Apis M that we have. So they may abscond or actually migrate to a new location or shut down their brood rearing and wait it out. Again, the cold or the length of day are not issues for these species of bees. But here in our area, our Apis M consists, by the winter cluster, they consist mainly of the long-lived survivor mode bees, eschewing brood rearing about a month before reinitiating continuous brood rearing from January onward. Did you know that's when they start up? In January. So he had some charts, and I don't have them yet. I'm not there yet. He had some charts showing the decline of the size of brood as the season goes on. But in January, they start kicking off again. Then the last thing I had from last month was that Randy Oliver suggests that colonies that are awake or active under the lid at a winter inspection, he believes typically have a problem. He likes them to be a nice-sized, calm cluster centered mainly in the lower brood chamber. He goes on to say, and I don't know that I can agree with that. I feel like my clusters are always in the upper brood chamber. Randy Oliver is in Northern California, so it's a different winter than it is here. But anyway, he goes on to say that temperatures between 55 and 60 are damaging for the winter colonies. It is warm enough for actual foraging, but there's nothing out there. It's not quite cold enough to form a tight cluster, but it's warm enough for them to establish a brood nest. Much energy is wasted as the colony breaks cluster each day in preparation for possible and often fruitless foraging. So while we look at those days as, ooh, it's so great to have that, that either late warmth that we're having now or the early winter warmth, it's damaging for them. They expend a lot of energy back to the cluster, out of the cluster. There's nothing for them to get. So that changed my opinion on those, warm days very early in the season. So Jim went on and talked about how the bees keep themselves warm, disengaging their wings from those wing muscles, but vibrating. And then again, the very important need for moisture mitigation. I talked to Jim on the phone today, and we talked about, there are several points as I go through here that I feel like we kind of go in circles, and he says one thing, but we get back to maybe that not being the case, and we'll talk here in just a minute about feeding pollen and what does that do. Jim said, to just reiterate, all beekeeping is local. Our climate is different than Randy Oliver's climate. Our pollen supply in late summer is very different from Randy Oliver's pollen supply in late summer. So we'll go ahead and go through this, but again, he's writing from a different area, so let's go ahead. So this is Jim writing to you. In the previous article, he summarized the basic mechanics and physics of the winter cluster, but still had some leftovers that he wanted to talk about. Researchers have shown that the optimum size of the winter cluster may vary with climate and other factors. Very large clusters may overwinter better in cold climates. What is normal size clusters may overwinter better in moderate cold climates. Do you feel like you have an impression of your cluster? I mean, I was very surprised when I found that dead cluster that was gigantic. Of course, I was very disappointed because I hate to miss out on that. Do you feel like you have an idea for what's a normal cluster here?
I don't think there's anything normal with beekeeping.
Okay, I'm glad to hear that because that's sort of how I feel. Do you get in and look at anything in the late winter like that? On a warm day, are you popping the lids and seeing what you see, or?
If it's warm enough, I might a little bit. But I'm feeling weight more than anything.
Weight in the back, lifting on the back. To see, how many of you have been lifting the backs of your hives in the past couple weeks? I have done that a couple places, and I feel like I have very little storage going into winter. I'm kind of concerned, actually.
Yeah, it's
Is anybody else with me on that, or do you think they're restocked pretty well? I mean, I do candy boards no matter what I feel, but I've just felt like, oh gosh, no, I keep being surprised by that. Okay, well good. So what is the normal size cluster? I can't tell you. Thermal regulation becomes an issue when colonies are too large or too small for their climate. Inappropriate cluster size can cause disruption in cluster water balance. Absolutely. I mean, this is very logical. Locally adapted bee races will be more resilient in overwintering. And that's what we have been hammering on for years, not just in this club, but just the state of Indiana clubs. We need to be buying our bees here. We need overwinter queens. We need nukes that have overwintered. And how many of you have tried nukes for this year? How many people made nukes this year? Really? How many of you were at Nuke Fest? How many made a nuke after Nuke Fest? Ah, come on, people. I will tell you, making a nuke is a great thing to do. You need to do it next year. And honestly, I think overwintering nukes is easier. Do you? I mean, I push them together and put insulation around them, and plus it's not so devastating when they die. But I haven't lost any nukes anyway. I think losing a big colony is easier to lose a big colony. There's a bigger space to feed and keep warm. Bees store honey to eat during the part of the year when there is no nectar flow. 6 to 7 months here. I'm amazed we can winter them over at all, honestly. 6 to 7 months is a long time. In a normal hive of 10 to 15,000, that's your winter population, obviously your summer population. Each bee will eat 1 to 1.5 milligrams per day per bee. Feeding early allows bees to arrange their stores to easily move them through the winter. How many people have been feeding already? How long have you been feeding? A month. Great. Okay, good to know. And I think this talks a little bit about feeding. I'll read this again. Go ahead. Go ahead, Paul. All right, here's the chart about brooding. Colonies typically initiate brooding in midwinter, which is going to replace workers which have died over the winter, and it's going to build up the colony for early spring forage. And then, of course, because the brood is increasing the population, then we're going to accelerate the consumption of winter stores. So going back to that late winter, anytime you have a possibility of looking at your candy board, there's nothing out there for them to get, you should go ahead and do that. I'll go ahead and do this at the end. The smaller the cluster, the smaller the brood nest it is able to maintain. Well, that only makes sense, right? I mean, there's only so many bees and then you have to cover all the bases. Small colonies going into winter will not build up quickly in the spring. They can't. I don't know how I feel about that. I think if you have a super queen and they winter over well, she can go gangbusters in the spring.
And you have to have enough bees to cover the room.
Well, that is true, but I mean, okay. Okay. I'm not a scientist and Randy Oliver is, and he obviously gets into his bees and weighs them a lot more frequently than I do, so go ahead. All right, pollen consumption. Pollen stored in the fall is critical for colony buildup in late winter and early spring. During summer, only a fraction of the sampled workers had pollen in their gut in the summer. So they're storing it, I assume. They're putting it away and they're feeding it to the bees. During a winter sample, all the workers had pollen in their gut. The relationship of pollen to winter bees is still unclear. And Ron, you told me winter pollen patties are different from spring pollen patties. I know, Matt, you told us that. So winter pollen is more carbohydrate and less protein, because we don't want to stimulate brood rearing. Is that right? Is that why?
The winter value, couple percent is pollen, then 20%.
Okay, and again, I'm gonna address pollen consumption in this circular, which is from 1940. So that's a great thing. Okay, so after consuming pollen, bees gotta go. They gotta go, okay? And they will not go inside the hive if possible. They're gonna wait for that warm day that they can make cleansing flights. If the cold weather is prolonged, they can't make the cleansing flights, then they start going inside, then we have a water imbalance because of the moisture from the poop in the nest, and we can cause bee dysentery. Is this dysentery here? Yeah, so.
Well, I mean, it's been going to the bathroom, not very good.
But
But you
cleansing,
can see this in a warm day.
cleansing flights, you'll actually see, like out in the snow, it's kind of yellow. There was like a big nuclear bomb scare in Cambodia, and it turned out to be bee cleansing
That one had a
flights.
problem.
So that isn't cleansing flights, that's dysentery coming back to the hive. Okay, I told Jim I was so happy that I got to talk about the section about poop. I really appreciated that. There is scant, if any, evidence supporting that nosema causes dysentery. The only relationship between nosema and dysentery is when a nosema-infected bee defecates in the hive and thus transmits it. Well, that to me is a connection. But factors that can cause dysentery: small clusters, having trouble with water balance, poor quality pollen stores, irritating the gut. I cannot control the quality of the pollen, so that I feel like is out of my control. Heavy feeding nurse bees in spring confined by foul weather. Again, something I can't control. Feeding of poor quality pollen supplements. That I would like to be able to control. Go ahead. The need for stimulatory feeding is climate specific and purpose specific. For instance, getting ready for pollination. You've moved bees and want to get them ready. A hive with good stores in late winter will not increase brood rearing due to feeding. I thought it was just the opposite. I thought that was part of why we, of course that's talking about late winter, I'm talking about spring. Overstimulation may cause fruitless foraging and just wear bees out, and I think he addresses that here. Locally adapted stock will use more discretion in accepting stimulatory feeding. That's an observation. I do appreciate that bees won't eat it. If they don't want it, they don't want it, and that's okay. So that makes me feel a little bit better in just providing it, but can't encourage enough that you get your bees locally. Go ahead. I cannot, oh, okay, so this is Green Elder. This is Farrar's excellent bulletin. This is it, and I'll read to you what I highlighted through that. It is from 1944. It was very easy to find, USDA Circular number 702. That's all I put into Google. It came right up as a PDF. We can certainly put that on our Facebook page, but let me just read to you what Mr. Farrar had to say. He was an apiculturist in the Bureau of Entomology in charge of the North Central States Bee Culture Laboratory at the University of Wisconsin from 1931 to 1938. So he's talking about management of bees and the opportunities to regulate the development of bee colonies regardless of weather, which is something we all need to be able to do, at least assist them against different weathers. He says, formerly, good weather throughout the spring was necessary for the development of a colony, not only so a variety of plants would produce pollen and nectar, but so the bees could gather these foods for use in raising young bees. We now know how to provide the food required for brood rearing, making the colony less dependent upon early sources of pollen and nectar. Successful management demands that colonies be developed for the honey flow rather than on the honey flow. Okay? He wants to produce honey. So he's suggesting that we should be managing the colony to be ready for the honey flow, not wait for the honey flow in order to sustain itself or grow. And then he goes on to say, probably less than 10% of the available nectar supply is gathered by the 5.5 million colonies of bees in the United States. We have less colonies than that now. Okay, and he's saying less than 10% of nectar is gathered by honeybees. So what does that tell you about what opportunity there is to produce more honey? There's a lot more nectar out there than is being brought in. Beekeepers have an opportunity and a challenge to contribute more fully in the development of our agricultural resources by supplying the bees needed. The pollination of fruit and seed crops will be proportional to the increase in honey production because both depend on the number of blossoms visited by the bees. I guess I perceive always that we have so few honeybees that I had no idea that we're only even getting 10% and that if I can produce beehives that are booming with population, not only is that a boon to me as a honey producer, but it's also a boon to the ecology of my local area. So the more honey you produce, the more nectar is being gathered, the more flowers are being pollinated. It's all good. The more we can do, the better. In the United States, man has been the honeybee's worst enemy by his failure to provide adequate food reserves for their overwintering or to supply the needed hive space for the developing colony. The object of management is to maintain the colony in a maximum state of productivity, even though this means that both the queen and the workers will wear out more quickly. It sounded a little inhumane. The honey, which they're insects, I get it. The honey production for any given number of bees increases as the population of the colony increases. For example, while 4 colonies, each with 15,000 bees each, so that's a winter population. If 4 colonies with 15,000 are producing 100 pounds of honey, 1 colony with 60,000 bees will produce more than 150 pounds of honey. A larger proportion of the total population engages in brood rearing in the small colony than in the full-strength colony. The greater gain made by the large colony is due to the larger proportion of field bees. So, again, you want to maximize your colony, not just to make more honey, but also because it's a healthier colony. It gets a lot more done. I guess I need to think more along those lines. The most important recent advance made in colony management came from a study of pollen requirements. Experiments on wintering bees demonstrated that the survival of overwintering populations was largely proportional to the amount of reserve pollen present in the hive. Guys, how can we know that? How can I know that?
The pollen's typically going to be either in the bottom box or on the fruit net.
So at this time of year though, I mean, if it's not there, it's not there.
There should be pollen in the hive, right?
Right, but how do I know what's enough? And what do I do if I don't see it? Has anybody looked for specifically for pollen stores? Is that something that you've been thinking of?
Well, no, but don't they, store pollen underneath the honey?
They put they put a thin layer of honey on top of the pollen, just to seal it.
Seal it in? Oh, okay.
But when the bees are raising brood, in the peak of the season, a typical frame of brood should have an arc of honey around the top, and it'll be fatter, the honey will be sticking out fatter, then there'll be pollen directly below that arc, in an arc form, and then the brood will be below that. So the queen lays eggs, the bees already have that honey and that pollen, they're ready, open cells polished, the queen goes, now she notices that the cells are polished, they
It
descend, and she
just
lays
seems
eggs.
like every time I extract, I've got a lot of pollen still underneath, still in the cells after I've extracted.
I don't know how that'd be in the brood nest, I think, not so much in your honey super, right? If you're
Yeah, when I pull
out
the,
of the bee.
yeah, when I get greedy, pull
But
the
typically,
side frame.
they'll prepare the frames for the brood with honey, pollen, the workers are doing this, and they lay eggs, and the queen lays eggs. The bees use those resources to feed the larvae as it's growing. So you'll watch the frame be depleted of its pollen and honey as the larvae is being fed and growing. They keep it right there close by.
Well, I guess maybe the question is if you're getting a good honey flow, is there ever a time when you're not also getting a good pollen flow as well?
There should always pretty much be pollen available if there's nectar available, I think.
Yeah. I mean,
There's
because,
pollen available when there's not nectar available.
yeah,
More often than not, for sure.
and because it seems like I can't think of too many times during the year
So did
where
we
they're
agree
not.
that pollen is more continuously available than nectar? Is that what
Yeah,
we
because they
agreed?
start,
That's what I think. I
in
mean,
February, I
dandelions
And
don't have
you see the
nectar,
big
right?
the weather thing as well, because nectar is produced in the evening, in the dark hours, by the
Right.
plant, and then if rain comes after that, it gets washed away, the pollen will still be available. So it won't get washed away.
And see-
The nectar evaporates in a certain time of day. A lot of nectar will evaporate by 9, 10 in the morning, from the
What
heat.
are they doing, like on wood chips and stuff like that? Aren't they pulling something that they think is pollen off there, like they're
Propolis.
pulling in spring?
They're eating propolis or something like that,
Yeah.
propolis or moisture. There could be, the pulp of some wood can be kind of sweet. Or they'll be on, these are just, it's in their nature to forage, and if it's warm enough, they're gonna go do something. So you'll find that if you have chickens in the cracked corn,
Oh, yeah.
it's just,
Birdseed, yeah.
they're just looking for something. That's the reason that they end up making a
It's
surplus
like
of honey,
horses, they're
because
eating something somewhere.
they just work with it no matter what, so if it's warm enough, they're gonna get out and and you'll see them on wood stations a lot in the early spring or late when it's warm.
So again, my original question is, are you looking for pollen in your hive? Just like the
I don't
year.
think I've ever seen a hive in Indiana that was healthy that lacked pollen,
Okay,
personally.
But
But
if-
I can't say that's, true all the time.
okay. So what makes you decide to feed a pollen patty?
The only reason I would feed a pollen patty would be to do Excel builder, which is what I would be using to graft beans into.
In the spring?
Spring, early summer, when we're grafting beans. I might choose, I might choose to feed a nuke, but I'm getting ready to start feeding pollen patties right now because I'm getting these ready to go to California.
Right, totally different, because you're trying to stimulate.
But that's the,
Right, right.
the only thing I really feed pollen patties to, like I said, is the queen cell builder.
Okay. So I just said, now, he goes on to talk about, this is just funny and I won't linger, but he says, no satisfactory complete substitute for pollen has yet been devised, but when 3 pounds of expeller processed soybean flour is mixed with 1 pound of pollen, approximately 30,000 bees can be reared as compared with 4,500 bees for 1 pound of pollen alone. So they were mixing pollen and soybean flour to make a cake back then, and sometimes with 2 parts of sugar syrup. He says, brood rearing, which is the basis for colony development, can be regulated independent of weather conditions by feeding these pollen cakes. Supplemental pollen feeding is equally important for the development of new colonies from package bees, which I think we all agree, when you have packages, you have to feed. And then I won't even read this, but I will tell you, if you go read it yourself, I thought of Matt when I was reading through it, the importance of good stock. Now remember, this was back in 1940. He says, artificial insemination had been available since 1925, but until 1943, very few artificially inseminated queens were capable of laying a sufficient number of eggs. Obviously, that's changed over time. He talks a lot about 2 queen colonies, and the success that they've had with 2 queen colonies being heavy honey producers. So anyway, this is very available if you'd like to read it yourself. We might be able, we can put a link to that. We can just put a link, that last slide had the link to this document, we can put that up there. So, we will sell raffle tickets to these 3 items. We will take a 5-minute break, and if you have questions, we can talk during that break with whoever